All right. So good afternoon, everyone, and welcome to my talk on AI security, adversarial AI attacks in cybersecurity. So my name is Thomas, and I am from the University of Sunderland. So my primary research areas, amongst other things, are in AI security and in OT security, and how to amalgamate between the two. So with that in mind, for this talk, I'd like to give a quick overview of the current work surrounding adversarial AI attacks and how they have been adapted in cybersecurity. And more importantly, I also want to discuss and share my thoughts in terms of the different AI targeted attacks that has been identified in existing research. So with that in mind, so first of all, so here's a quick overview of what the topic is going to be, how this talk is going to be structured. So first of all, we'll be looking a quick overview rather into security analytics, and we'll be looking at the different AI-based attacks. And before we conclude, so we'll be having a quick overview of a new framework that has been created by Mitra, the same folks who created the well-known Mitra attack framework. So they have recently come up with new frameworks on addressing AI model-based attacks called ATLAS, which stands for Adversarial Threat Landscape for AI-based Systems. So when we talk about security analytics, so what is security analytics? So as everyone in this room will know what security analytics is, but still bears a little bit of a quick overview to make sure that we are on the same page. So when we come to security analytics, so security analytics is all about identifying previously undetected threats in large-scale environments. So that typically involves leveraging the different data that we gather from different points within the enterprise network, be it network logs, be it user access logs, etc., feature correlation, event correlation, and then we automate the detection process through running it past an AI or machine learning classifier. So when it comes in more recent times, due to the large amounts of data that have been generated by different SIEM solutions in recent times, we have decided to use big data analytics along with other large-scale machine learning models such as deep learning and reinforcement learning, etc. So typically, when it comes to security analytics, here is a very generalized version of how it typically works. So given the network logs and the user access logs and the different bits and bobs of information that we get from different points within the network infrastructure, we typically try to generate a graph or something similar to that effect in order to represent the features in a more coherent manner. So in this example, what we have done is we have represented the features that we have gathered in the form of a graph. So here we got three different features. We got the fairly self-explanatory, and here amongst the different fields, so we have different edges, so to speak, of this graph. So what we want to do is we want to detect which of the network flow or the features are indicative of a potential attack. So in this case, so we represent all of these features that we gather in the form of a graph, and then we pass it through to a machine learning or AI classifier. So when it has done its job, typically we will end up being able to identify a potential attack, which are highlighted in red. So this is how typically machine learning models or AI models are leveraged in the context of security analytics. But in more recent times, precisely because of how prevalent AI-based detection solutions have been adopted in threat detection in recent times, and not to mention the immense popularity of LLMs such as Llama and ChatGPT, so on and so forth. So attackers have attempted, and in some cases rather successfully, in order to compromise the underlying the underlying AI model or the machine learning model. So the question then becomes, what are the different techniques, what are the different attacks that have been attempted against AI models? So generally speaking, they can fall under one of these four main categories. So one is called evasion, second, poisoning, three, inference, and last but not least, we have prompt injection. So when it comes to evasion, so what is evasion? Evasion, well, we all know what evasion is, but in the context of AI-based attacks, it's all about trying to pass a set of features and engineer them in such a way that when it gets passed through to a classifier, the classifier is none the wiser. So in other words, so given a set of malware features, if we pass them as is, the machine learning model will immediately flag it up as an attack, no doubt. But what if we structure these features in such a way that the machine learning model or the AI model thinks it is quite benign? Then that means that we could bypass into the target network infrastructure, and we can perform all kinds of lateral movement and data exploitation, so on and so forth. So when it comes to one of the techniques that we tend to find that has been used in AI-based attacks is evasion attack. So evasion attack is what is called the deployment stage attack. So meaning that this evasion attack typically takes place when the model gets deployed in a real-world environment, because the model has been deployed, it's already live and well, it's running, so here is our target. So as I previously mentioned, it features the use of specially crafted features. So usually from a red teaming perspective, it is used conjunction with a typical attack flow. So, and ultimately, the question then becomes, what is the main purpose of evasion attack? It's twofold. One is to fool the machine learning model or the AI model in such a way that the AI model deems the features to be benign and thereby allows the attacker to get inside the infrastructure, the network infrastructure, and do all kinds of weird and wonderful stuff. And the second benefit of it is that it targets the accuracy of the AI model. So the main reasons for the evasion attacks are twofold. So with that in mind, I'd like to share with you a very, because I also like cats as well. So, and this paper, in my opinion, provides a very good overview of what evasion attack is, and also the cats as well. So when it comes to evasion attack, so here in this example, we have an image of a cat, and then we have an AI system. So typically by default, when the image of a cat gets bypassed, the AI model will immediately say, okay, this is a cat. If it is not a cat, then it's not a cat. But when we go about adding adversarial noise and to the image, so from the naked view, from the naked eye, the image still the same as far as human eyes are concerned, none the wiser, still the same. But when it passes onto the AI system, the same AI system, then it gets misclassified as a dog. Obviously it isn't, but this is how it can. It can be, the AI model could be tricked. And more recently, we have found that this can be done through machine learning models such as generative adversarial networks, which allows for the automation of allows for the addition of noise and distortion of the features, be it image, be it video, be it network features, etc. So next up is going to be poisoning. So poisoning attacks against AI models is where the attacker tries to corrupt the parameters of the AI model, as well as the features that are used in order to train the said model. So you might be wondering, okay, Thomas, so in this case, we got the AI model. How does the attacker figure out the hyperparameters, i.e. the details, the inner workings of the AI model? And that's a very good question. So the reason for this could be traced to two reasons. So one is the fact that most of the AI models that are used the AI or the machine learning frameworks that are used in industry are more often than not open source. Like we're looking at like PyTorch, TensorFlow, etc. And more often than not, given the nature of it, we could identify the source, we could identify the parameters, and the second means is through simple, good old try and error. So if you look at the AI model, the solution as a black box, what we would do is in typical software engineering endeavor, we would throw it with a bunch of data, we see what the results are, and then we make some educated guesses as to what the hyperparameters are going to be. So when it comes to poisoning attacks, so the poisoning attack is a bit more overarching. So rather than just targeting one or the other in terms of the data or the model, we could target both. We can poison both the data or the model. More specifically, the hyperparameters of the AI models could be targeted. And in a more extreme example, we could also include what is called backdoor attacks. So the backdoor attacks is when the attacker creates corrupts the models, the AI model or the data used in the training process in such a way that given a specific class, following on from the previous example, it would be cat, for example. So given a cat, image of a cat, we could craft the AI model to give a response like, I don't know, maybe a squirrel. So in this case, so we could do that as well in a worst case scenario. So here it is. So when it comes to poisoning attacks, so poisoning attacks are typically more prevalent in training models that feature distributed machine learning techniques, i.e. federated learning. So in a federated learning environment, each participating users has their own set of local data. Each of them train a local machine learning model. They all pass it onto a global aggregator. The aggregator creates a global model that is shared across it. So in order for federated learning environment, federated learning-based AI training to work, all the participating devices have to be accurate, have to be, in other words, play by the rules, so to speak. But more often than not, doesn't really seem to be the case. So this is where the poisoning attack comes into play. And nowadays, especially when it comes to like device-based security, more and more solutions, we get to see more modern detection solutions using some variation of federated learning and model sharing and threat intelligence sharing, etc. So typically gets exploited in use cases like this. And next up is going to be inference. So inference is all about compromising the confidentiality of both the data and the model. So in this case, inference is all about treating the AI model as a black box, and see how we could and try to craft the features in such a way that the model ends up giving us certain privacy-preserving information. So it's typically inference, inference attack is all about trying to identify the details, trying to get the AI model to disclose the information that is being used in the detection of threats and malware features. And I also said in this slide that it is iterative in nature, meaning what I meant by it is that it basically means it is a try and error. So we craft the features, we pass it onto the model, see what comes back, we do it, we improve upon it again, we get the response, and we do it over and over again. And here, as far as here is concerned, just like with the previous steps, this could be triggered, often used together with gun or generative adversarial networks-based attack vectors. And last but not least, we have the good old prompt injection. So recently I saw this, there was a YouTube video by, I believe it's called Live Overflow, that provides a quick demonstration on how prompt injection works. So the target of the model was ChatGPT-4. So what he did was he showcased a series of prompt injection attacks that are crafted in such a way that the ChatGPT ends up divulging certain privacy sensitive information. So which was quite cool to see. And he also demonstrated a dojo a playground, that where people could play around with prompt injection. So the prompt injection, as I alluded to earlier, is all about so it's targeted against large language models. And it's all about trying to craft the prompts in such a way that it bypasses predefined rules that the creator, or in this case, OpenAI, has set up. Yeah, so in this case, and so the question then becomes, so far we talk about what security analytics is, and we also look at how the different types of AI-based attacks that have been identified in existing research. So the question then becomes, what are the different approaches that people have used in existing research in order to address that, in order to detect them, in order to get around that? And more often than not, based on what I've found so far, at least, is that most of these solutions typically involve the use of clustering-based approaches. So clustering or adding a layer of additional machine learning model in order to automate the detection of the process. But even then, despite the best efforts, so current solutions are quite limited in terms of two areas. One is in the overall coverage of the AI-based attacks, and two, in terms of the amount of training time and the performance overhead associated with using them. So given the recent developments of AI-based attacks, so the solutions against them are still in the early stages as well, but it's kind of good to see what the future brings. And before I end this talk, so what I like to share with you what the more recent framework that Mitra has created and made available, so which is called the Atlas model, which is the adversarial threat landscape for AI-based systems. So these are the same. So if you look at the different aspects of this framework, you will realize that they are eerily similar to the Mitra attack framework that has been used to understand the behavior of APT attacks. So in this case, and that's no surprise because these are the same folks that have created the Mitra attack framework. So as you can see, same steps as before. We got the recon, we got initial access, etc. But if you look at the different aspects of it, more often than not, it always comes down to two things. So either the exfiltration of data or the compromise of the parameters and the training data rather. So it's still, it is quite interesting to see what the future brings and the work that still needs to be done. All right, so as far as the talks are concerned, so here, the talks is concerned, that's pretty much it. So here are the references to some of the papers that, in my opinion, are quite useful in order to understand the different types of AI-based attacks. So thank you.
Any questions?
Yes. Yes, that's a good question. So, and actually I've seen it, but I can't remember from the top of my head precisely which research paper that was, but there has been attempts that people have done it successfully. Yeah.
Round of applause, please.
All right. Thank you.